All right, everybody, let's get started. So thanks for coming to this talk. My name's Julian. I run developer relations at a company called Flox, which is building stuff on Nix. And today we're going to talk about containers, Nix, and open source. So I'm particularly excited to talk about this at this venue because I think there is a lot of interesting tooling coming out right now in terms of developer tooling and how we engage with our environments, our machines, our servers. If you just showed up to programming or open source in general, you're in a really good time to show up. If you've been around here for 20 years, also a really good time because everything is getting much better. So yeah, what I want to talk about a bit today is kind of placing a technology that we're somewhat familiar with. I'm going to use Docker as a shorthand for containers often through this talk. But the containers in the arc of technology and where we're at and the long kind of time that took us to get to containers and Docker and where they are today. And we're going to talk about the development of Nix. So I think these two technologies, containers and Nix, have a lot of good things to do for us in terms of developer tooling, in terms of how we run environments, how we run multi-stack environments on our machine. So I'm going to introduce Nix, and we're going to talk a bit about like what the big idea is with Nix. Millions of words have been spilt on what is Nix, and I'm going to try to keep it like nice and concise, because there is a really important idea here for open source at large. And we're going to try to talk about Nix packages and kind of what Nix can do for open source at large. So let's get right into it. What do we as kind of engineers want, right? We want to run code as simply as possible. I think most of us have probably gotten to a README and started looking at the setup steps and wondered, okay, is this going to take me all afternoon? Am I going to have to like overhaul my machine? Is the other projects I have set at this particular version of Go, Rust, or Python, is it going to break? What am I going to have to think about when I just want to test out this code that someone else has on GitHub on my machine, right? This is still a good question. Docker offers us some really good answers. Nix offers us some really good answers too. We want to build code for multiple stacks, languages, and platforms. Same deal. If you show up, if you download you clone someone's README, clone someone's repository, and start setting up, there's some JavaScript in there, there's some Rust, there's some Go, it's WASM. Like, how am I going to do this? We want to be able to do this as simply and as quickly as possible, and hopefully repeatably, right? Do it in a way that can have an assured build system bundled with our code. Again, this is what a Docker file gives us. It gives us a spec for building this entire project in a way that the developer specifies, right? Again, here, there's some differences between how Nix and Docker arrive at this goal, but they do so in ways that are quite interesting. And finally, we want to share code in the open. We don't often talk about how to build the projects that we're given when they're in open source. You get some instructions, maybe you like type some commands imperatively and hope that it works out. But doing repeatable build systems is something that we're still trying to find good answers for. Docker, again, here has some answers for us. It also has some significant limitations in solving this. Nix has some good answers, and it's also complicated. We'll get into that. We'll get into why. But this is an important question for open source at large, is when you share code with the world, how are they supposed to build it? And are they sure that they are running the same code that you, the author, the builder, intended for them to run, right? So these are kind of, as engineers, we would love for all these three things to be true. I show up in a README, it's one command to build the project, run it, and it's built in the exact same way that the developer intended, and there's nothing hidden about the build process, and I can see that it's repeatable. Right? This is transparency, and this is kind of what open source is all about. Dream state, this would be great. And the good news is that in 2023, we are slowly but surely getting there. So let's talk about the kind of big picture timeline of how getting to this goal, where we've been getting to this goal, right? So these a little stretched? No, that looks okay. So way back in the day, I believe it was Unix version 7 or something, they introduced this command called change root, chroot, right? And what this does is that this allows you to declare a new root for your file system. And what this means is that you're able to declare little like subsystems in your machine that act as little isolated submachines, right? And people were like, oh, this is cool. I don't have to be on the same kind of shared terminal as everyone else or share my namespace and like have a nice little isolated bit of the computer. This is interesting. What more can we do here? Fast forward more over 20 years, you get to FreeBSD jails, right? And jails are a more evolved concept here. I'll admit I don't like know the internals of FreeBSD jails and didn't research this deeply, but they were the initial ancestors of containers, right? And they allowed you to have kind of a more isolated thing in your system as well. Getting into post-2000, you have the first commits for Nix were in 2003. This guy called Ilko Dolstra started this project. He would defend his thesis in 2006 around a way to build the purely functional software deployment model. And this basically was a way to build software in a way that was reproducible, that was transparent, that was self-contained. It allowed you to have nice little isolated sandbox for building software. At the same time, I think it was 08 LXC Linux containers came out, and this was really important. This was finally we had like really legit production containers we could use on Linux, and this really kind of spurred development on things like Docker that would come after. So if I don't know about you guys, but like when I first started like paying attention to tech was maybe like, between 2016 and 2012, and I thought this stuff was just so genius, next level. And looking at it now, I look back at it and I'm like, we had nothing figured out in 2010, you know what I mean? So, this is good. So Nix 1.0 was, I believe, 2013. Nix OS stable, which was kind of an operating system built on this model of purely functional deployment, was 2014, 2015. Docker was started in 2013, but really I think went public in 2015. 2015 was really when it launched, and kind of 2015 after was like Docker only, Docker everywhere. Kubernetes was 2017, and then we're getting kind of closer to today. Docker is kind of the way to share and give developers a way to just run exactly what you're running. We have Docker Hub, we have all these wonderful tools. And at the very end, we'll talk a bit about Nix packages and kind of the Nix collection of packages is kind of the equivalent to Docker Hub, I guess, that is at over 80,000 packages. And we'll talk about like kind of what that means. So a lot of good stuff has happened in the last 10 years, and this is great. So brief kind of like chat on containers. Like some of you maybe know this, but let's just go over this. On the left, you have kind of a diagram of how a VM is organized on a machine, right? You have your server, you have an operating system on this server, you have a thing called a hypervisor, and this manages kind of another machine with its operating system and then your application, its libraries, etc. This is just another machine on top of your machine. This is kind of a, fairly well understood concept. Docker kind of changes that model in that it removes the need for a hypervisor, and the Docker engine just sits on top of your operating system and handles these multiple little containers, jails. You'll notice that renaming jails to containers was a genius marketing move. They're now called containers, and you can have multiple applications that run in independent little sandboxes. And Docker manages how to run these little things on your machine, right? So this is nice and isolated. You can run multiple to the extent of your hardware allows, and this model has kind of become the de facto way to work, right? You define what we call a Docker file, a spec of what to do to load this container, to create it on your machine, and anybody can kind of run that, and that's well and good. It's really hard to understate how much better this has made developers' lives, right? This has been a significant productivity boost, sanity boost, and just shareability boost, right? So, we talk about how do we actually share the code how do we actually share code in open source. Docker has made this a lot easier for us to do. And I don't know how you would quantify how much simpler this has made it, but it is significant, right? Now, so Docker is a de facto developer environment, artifact generator, and kind of publication format. This meme is funny. It works on my machine, works up your machine, and this is how Docker was born. This meme is funny because it's true, right? The solution to how do I get to make sure that you're running the same code that I'm running is, well, I actually am going to ship basically my entire machine to you. You get another operating system, you get an OS layer, you get all the libraries. We just rebuild it in this tiny thing and we give it to you, all right? So, we talked a bit about kind of developer environments, but in terms of artifact generation, when you give someone a container, effectively, you can give them a production artifact. And this is how a lot of people run their production systems today, is with containers, right? You have even companies like things like Kubernetes that allow you to run whole clusters of containers and manage systems this way. Billions of dollars worth of companies that are in this space trying to give tooling to make this work better and help companies deliver most of the software you know today. So an important kind of thing. The binary publication format, that's probably the wrong word for it, but the ability to kind of give a binary this is what we as a project determined to be this is our delivery system, and it's Docker. Docker Hub, which was recently in the news, but Docker Hub is just that. And a lot of open source projects rely on that to give signed artifacts. Here's our binary, use it, and it's one Docker pull away, right? So super good. However, what if we didn't need to ship many computers around, right? In a way, there's something that's kind of brute force about this. We looked at the problem of how do I recreate this on your machine, and we decided to ship the whole machine, and this is how everything runs now. And if you stop for a second, you're like, well, I mean, is there a better way to do this, right? Because this is kind of a lot, and I think you could say that the Docker is quite heavy and consumes a lot of resources. And if you're running a lot of Docker containers on your own little personal machine, you end up kind of having to clear out a lot of images, and it's a heavy thing. It's a heavy thing. But even conceptually, is this really the best model we have for being able to share software from one machine to another, right? So this is where I show you Nix, right? So my goal here isn't really to get you to believe that Nix is better than Docker. It's not. I think my conclusion would be that Docker and Nix work really well together because they are very good at different things. But one thing I think where Nix does better is specifically for developer environments, right? I'm running code on my machine, and I want you to recreate it. Classic works on my machine problem. Nix does this in a way that does not require you to share an operating system layer, to have this whole complete Docker container and this whole mini computer that I give you, right? So I should have asked this beforehand, but how many of you have used Nix before? One. Dope. Cool. So great. No, this is great. So Nix, I bring this up because I think Nix is a really important idea in this respect. And I think if you look at the arc of technology, Nix has something really important to give us here as a superpower, right? And so what's Nix's big idea? Classically, when you go and install software on your, let's say, Linux machine, we're in Open Source 101 here, it goes and it hopes to know where everything is going to be on your machine. It looks up /user/lib. It expects etc and certain directories to be in certain places. It expects to be able to link to certain static libraries. It assumes things about how your machine should work, right? And this is true for macOS as well, right? This is true for most operating systems work. Nix does away with this model. It says, I'm going to assume absolutely nothing about your machine. And everything I download, everything that we share, everything that you build is going to live in one place, and that is this directory called /nix/store, which we call the Nix store. And so everything gets put in there, right? Your binaries, libraries, the whole graph of dependencies that I'm giving you. The second part of this trick is that everything gets identified by hash. So if you look in the Nix store, and we'll look in mine in just a quick second, everything gets identified by a hash. And so in this case, for example, the ripgrep package, it's version 13, has this long hash in front, and that hash summarizes everything, all the dependencies that go into ripgrep beforehand. You get the whole graph of all the things you need to run this program, right? So if I switch one library out, I change one version, the hash will change completely. So if you look at a Nix store, you end up with maybe 7 different versions of Python. They're all sitting comfortably next to each other. They're identified differently as far as Nix is concerned. Python has all these different versions. Now, running 2 different versions of Python on a classical system, you'd have to just remove the old one and then add the new one. Now I've upgraded Python. I get my one version, right? We're kind of used to having these version conflicts between it. And this is kind of the problem I was talking about earlier of what if you need to actually run different versions of a program for 2 different repositories? How do you do so, right? And how do you assume about the contingencies of what every program on your machine needs? Nix makes this incredibly transparent. And that's really its kind of conceptual thing. And if you take this idea seriously, there's a lot of interesting implications that go with it. So I won't kind of like go into this, and I'm kind of just like throwing it at you, but if you take the implications of this idea and build them out a little bit, you end up with this Polyglot package manager. You end up with, like on Mac you have a homebrew, and on Debian you have apps. You end up with Nix being able to build and share and reason about your machine for any stack. And because it can do that, it can also do it for any architecture. So what we end up with is having a package manager that is truly polyglot, right? You can do so for any stack, any architecture, and that's what the package manager is. So this is already great. This is already like a really cool superpower, right? Nix is functional, right? So you also get this package management language with it. Everything in it is just functional code. And so you can query it as such. And we'll jump into this in a second. And all this works with kind of what I think is one of the crown jewels of open source, and what I think is really underappreciated today, and I think will be of extreme value in the future, which is the Nix packages collection. And this is the package collection that defines all these multi-architecture, multi-stack programs, and is today the largest open source repo in existence. And it's a bit of a gem. So let me hop over the command line if I can drag this over, and I'll show you guys very quickly what a Nix store looks like. So where are we? I'm going to go to /nix/store, and let's look for, well, I just did ripgrep. Let's do that. Okay, this is ugly. That's really ugly. Shit. All right, a little smaller. That's better. All right, so we have all sorts of ripgrep files. These are all the same versions. I mean, that's not a great thing. Let's do Python. Actually, I know that there's too much Python, so let's do Elixir. Elixir is a programming language. I dig it. I've used it. I've updated a couple of different versions. So you can ignore the DRV files for a second, but let's look at this guy. So what's in these files, right? These are all the binaries. This is everything that's on your system. So /up Elixir. And it's just a build. If I look at the binary, it's just Elixir. I have all these happy versions of the Elixir programming language that are defined in their individual little hash-denominated directories. And all these things are just, that's just it. And if you wanted to switch, let's imagine that I wanted to do, actually I'll show you, I can just do this. I don't have to talk through it. If I wanted to jump through different versions of Elixir, I would do, I'm going to get this wrong. Something about the Elixir. Okay. That's fine, don't worry about it. Elixir-V, Elixir-14, cool. Now let's do -1. 13. I do this. It doesn't exist. I should have probably tried this beforehand, huh? Oh my God, what was this called? Yeah, -1.13-1. 1-13 dash. Oh my God, am I dumb or something? All right, last try, I promise. All right, whatever. My point is that when I'm switching between Elixir versions, these are just symlinks, right? I'm just pointing to like different places in the Nix store where these objects exist. Again, like this is incredibly difficult to pull off in a classical system. you can't easily switch between versions because it can't think about different versions of Python. It doesn't know how to because all the languages themselves have defined how they interact with your system. So in a way, it's kind of the like one use standard to rule them all. But in a way, it's not really that because no one's ever really tried to build a universal package manager to this extent, right? So that's kind of the big idea with Nix. So this is incredibly illegible here, and I apologize ahead of time. But one cool thing you can do is that this is the graph of Git, I think it's 2.10 or something. Ask yourself this. How would you reason about the graph of dependencies for any program on your Mac computer? Could you draw it up? Could you show the transitive dependencies all the way down to the root? With Nix, this is trivial, because this is how Nix trees are defined, right? Every definition of a package comes with the entire tree of dependencies and dependencies of dependencies, and all the way down to every single thing that defines this package, right? So you can reason about it this way. And this is a very nice, to give you an example of like a way this is really nice. Let's imagine that a CVE comes out one morning with OpenSSL or something, right? And you're running a production system, you're like, your boss comes over, hey, can you find every single place that we are running OpenSSL in production right now? And you're like, for this exact version. Like, okay, well, let me find on like where each version of this software is deployed and make sure I can patch it and then redeploy everything and make it whatever. This is one command in Nix. Find like everything in all the OpenSSL versions for the things that are deployed, what the versions are, cool. Override it, done. Something that would have been a red alarm fire, get all your DevOps engineers out of bed and let's do this over the next 3 hours becomes a 10-minute solve, right? That's a small taste of like the kind of things you can do when you think about software in this kind of purely functional way. So I talked a bit about Nix packages, right? Nix packages is a repository, right? So like you have, you know, I don't even know what the homebrew thing is called, homebrew, I guess. I took this graph from this website called Repology that kind of tracks all the different package repositories that exist. Down here, you kind of have like all the platform-specific ones. There's Debian in there, PyPy, homebrew somewhere there, FreeBSD. Oh, by the way, the axes are, this is number of packages in the repository, straight up. And this is number of fresh packages in the repository. And I think fresh packages is like the most, like it's the most recent ones up to, yeah, the ones that are the most up to date, basically. So this is Arch. This is Nix packages stable and also stable. I don't know why these two are there. I think they're different. This is this older stable version of Nix OS, we're like one release behind. And this is Nix packages unstable. So I'll get out of the way here. How's the view, rest of the world? You know, Nix is out here just hanging out, has more and fresher packages than anything else there. And no one knows about this, right? I talked to people at Nix. We have one dude who has worked with Nix before. And people don't realize that we have this resource, right? So marvel at this. Like, this is a win for open source, right? There's a win here that you have a clearly visible, inspectable package set for any architecture across any stack, right? So the Nix packages repository is also one of the most active ones that, you know, I think it was in October, GitHub had Universe, and it was, I think, 7 or 8 most active repository on GitHub. And here's an example, right? Like, this was last week, 218 authors, 943 commits, total of 31,000 additions and 16,000 deletions. I will say, because this sounds crazy, a lot of this is super automated. There's a lot of bots that are automatically like fetching new dependencies, bumping versions. There's a lot of careful automation in the repository for curating and managing these packages that exist. However, they're really good at this. Like, there's about 6,000 contributors in the Nix packages repository, and they're kind of good at it, right? This works. This really does, and especially for the unstable stuff, right? The bleeding edge fixes come out super quickly. The care and attention to upgrades is well done, etc. So I've kind of like hinted at like why Nix is really good for open source, right? Nix packages is the Library of Alexandria in my book. It's hard to compare it to other things that exist. Like, yes, Brew is fantastic, but does the entire world run on Mac? No, despite what Mac stands would love to believe, right? Is everyone gonna run on Debian? Yes, but again, like, these are all little silos. And you know, if you look at the history of how we've done packaging and how we've developed, let's just go with tech at large, we're all working these little silos, right? You have Debian doing its one thing for Debian and Ubuntu. You got Mac doing their one thing. You've got the Arch repo over here doing their own thing. And no one talks to each other. They all recreate the same effort, repackaging the same stuff, doing it over and over again, and their efforts don't cross-pollinate, really. And because they're in their own little silos, they have trouble attracting more people because the base of people that want that stuff is already limited, right? So maybe you can convince you can grow the pie of people that can package stuff for homebrew. Maybe, but it will be capped, right? So something that has worked really well for Nix packages is that since it's addressable to most, to different platforms, different architectures, different stacks, that attracts a wider base of people that can come back and want to contribute to it, that end up becoming maintainers or packaging stuff on the fly. And that leads to having better coverage, which leads to having more people getting used to it, which leads to better coverage, so on and so on. And that's why Nix packages has grown so quickly, right? Yeah, to me, this is one of the important kind of build recipe repositories out there. Why is this faster? So I guess I didn't cover this as well as I should have, but the nice thing with Nix is that when you've defined your kind of environment in a project with Nix, you're one command away from creating an environment with exactly those packages from either downloaded or on your system, nicely isolated, and a repository that's well packaged with Nix is one command, right? You are one Nix develop away from having your development shell automatically set up by the developer, explicitly configured without having any fear of your machine breaking because of this, right? I think this is a really underappreciated part of it. I can clone a repository, run Nix develop with a stack I have never used, or maybe a stack I use avidly, but all the wrong versions, and I can test it, try it out, run it, exit the Nix shell, and my system is undisturbed, right? Nothing has really changed. I can experiment without fear. And this is, I think, something that is, in terms of the ergonomics of developers as open source, this is a really powerful idea, right? And finally, a stronger open source community and platform is one with kind of more package caches and catalogs. We have less centralized repositories where everything lives that we depend on and whose say kind of rules how we work. One thing that's really nice with Nix is that if you wanted to start your own package repository tomorrow, you could fork Nix packages and change whatever you wanted and create your own little package cache, and congratulations, you're now serving packages, right? I mean, yes, there's lots of complexity in setting this up correctly. I'm like glossing over a lot of complexity here. But this is way simpler than, for example, recreating the Debian repo or whatever else you might want to do. I would love to see a future for open source where we have 1,000 islands of independent little people able to run their own package caches for their own builds, for their own communities in open source, and you're not kind of determined to, or you're not stuck with like one provider of open source, right? If there's only one centralized repository and that repository gets compromised or gets shut down for any reason, that goes contrary to kind of the hopes we have for the resilience of open source in the future, right? So a stronger future for me looks like something like Nix packages where anybody's able to override things, modify things, recreate things on their own if they would like to. So yeah, I mean, I hope the perspective didn't come through as like, don't use containers, they're bad and Nix is better, because that's not at all the point, right? Nix has nothing to say about deployment. It has nothing to say about how you take these superpowers and run them in production. This is what Docker excels at, right? And that's not going anywhere in my book. I wrote a blog post on kind of like Nix and containers and kind of how to understand the mental model of how these ideas work together. So it's on the Flox blog if you want to check it out. There's a lot more there. Yeah, that's kind of it. I hope I didn't run through that too quickly. You know, that's our website at floxdev. You can find me at URRACA 2_ on Twitter, and we're Flox Development on Twitter. The Flox CLI is kind of like a really easy way to get started with Nix. We kind of wrap a lot of Nix in ways that are super user-friendly. Worth checking out if you kind of want to dabble in Nix, but yeah, and it's open source, so go check it out on GitHub.